Hi, and welcome to the ONF Spotlight on 5G Connected Edge Cloud for Industry 4.0 Transformation. I'm Timon Sloan with the ONF, and today it's my pleasure to welcome Juan Santiago. Juan's head of Ruckus's CBRS business at CommScope. And Ruckus has been at the forefront of private wireless networks for some time now. I'm very pleased to have Juan with us today. I'm really curious to hear about what CommScope's doing in the CBRS space. So with that, Juan, please take it away.
Great. Hey, everybody. Really glad to be here. Hopefully, I'll be able to share some of the experience that we had in the field so far. Really deploying private networks. Mostly to enterprises. About 90% of the 100 or so deployments that we have out there are private networks to enterprises, and we really leveraged our experience that we had on Ruckus Wi-Fi to make CBRS as easy as possible to Wi-Fi, as opposed to being a complex cellular network. So I usually start out with, CBRS is a big enabler for private networks because it gives you the right of way of spectrum. Gives you the ability to actually deploy networks where before only mobile operators had that right. So with this, I try to show sort of the left side of this slide talks about here's what the mobile operators and the fixed operators, all those guys, they'll do stuff with CBRS as well. And that's all in good because the band has this dual personality. The stuff on the left, it's all about, public networks. It's about service providers. But the stuff on the right, it's really about enterprises and private networks. And it's really where things are shining. I'll spend my time on this. Mostly I spend the time on the strictly private networks here. These are high value use cases that really, a lot of our customers just try to do with Wi-Fi, and it just doesn't quite get there for reasons I'll explain here in a second. There's also a part of it that's about in-building coverage with, for regular cellular users. I won't spend much time at all here. That is something that you can do with these networks as well. But today we're just going to focus on the strictly private aspects of these networks. So why use CBRS when you have Wi-Fi or you have a cellular network provided by the mobile operator to jump on? And it really, CBRS and private networks using CBRS kind of falls in between these two areas, right? Normally, if you have a private network, most likely it's going to be a Wi-Fi network. And with a Wi-Fi network, you certainly have a lot of bandwidth. We sell Wi-Fi networks. We're in the Wi-Fi business. They have been for over a decade. But what we really found was that our customers were looking for that higher sort of quality of service that can only be provided by a dedicated spectrum, which is what CBRS does, and B, some techniques that are really kind of borrowed from the cellular world. Things like mobility, longer range is really an important one because the rules in Wi-Fi, you have to be able to share with your neighbor so they keep the power down. Therefore, the range is sort of limited to your building. Well, in CBRS, they kind of allow higher power. Therefore, you can actually transmit outside of your building or in big areas like mines or shipyards and things of that sort. And then security is a really important point. Having security end to end. Of course we know that Wi-Fi is secure, but it's about having security all the way from the client device and the SIM card that's in the client device, all the way to the core network. And what we like to say is that there's no CBRS with cellular technology without security. It's built in. You can't do without it. Now, of course, you can always rent or get coverage out of the cellular network, but that's really it. The kind of the issues with that is that you're not in control as an enterprise, right? You get coverage where the mobile operator puts coverage. You don't own the data. The data goes all the way back to that operator. And of course, with that comes latency. But most important is that now you have monthly fees, right? You have to pay for that network, like everybody else. Whereas in the Wi-Fi or in the private network, you own the network and you control that network, and basically you don't have monthly subscription fees or per data fees or per user fees. We like to say that CBRS is really a complement to these two technologies that are out there. There's for specific use cases, where Wi-Fi doesn't quite cut it, and you don't want to be paying the mobile operator for cell coverage, or they just don't have cell coverage where you need it. So here's some examples we like to talk about. Lots of them in many verticals. For this presentations with ONF, we're going to focus on the manufacturing and automation part of it. But I just wanted to kind of show you a slide that kind of looks at, there's all kinds of things. We had a session yesterday where they asked, well, what are these verticals that you can do with CBRS? And really what we like to focus is on, we as a vendor, we're not going to come up with all your use cases. What we do is we tell you what the advantages are and let you as a, in your own business, as an enterprise, to look at and say, here's what I can do with something that's more reliable, has longer range, and is more secure. That's really how we like to think of these. But I'll start out with some examples. As I mentioned earlier, we have hundreds of these deployments out there. Almost 100% of those are with partners. So we provide equipment to our partners who go out there and provide these as a solution to enterprise customers. And we have hit in every single one of these. I'll go into some examples specifically on manufacturing and maybe some industrial. Here's a fun one that we did with a company called Adabotics. And what they do is they do these little robots that are trays that are on rails. Basically, it's what they call vertical warehousing, where you get the 2 dimensions X, Y, but they also go in the vertical dimension, and they can basically automatically fetch different trays, different devices from essentially a cube type warehouse and do that all automatically. These little robots are on wheels, so they're mobile, they have to move around relatively fast. And when they tried to do this with Wi-Fi, they just realized that they just didn't have that quality of experience that they needed, and that reaction time, that low latency, and so on. So there is a video. Don't know if you can actually click on the Zoom here and get to it, but you can certainly go watch the video. It's an interesting thing about what Adabotics is doing, and they're using CBRS with their own private LTE network to essentially do what many people will call a 5G use case, right? Low latency robotics within a factory. Let's go ahead and move on to another example that we like to talk about, because this is, it's a venue. It's a large sort of seldom used facility outside of Phoenix. It's a racetrack. Those of you who are NASCAR fans might recognize this. But the thing is, the city is way out in the distance, and this is a venue, they use several times a year during the season. But most of the time, there really not much goes on here. There is a Wi-Fi and a DAS system, which means that the fans, when they come, they do have cell coverage when they're there, right? So it's good enough for that. However, what our customer realized is that these people in the center here, which are the race teams, they also need connectivity, right? And they need it, the few times of the year that they actually here. So it didn't make sense to basically vary wire or do, they basically said, hey, can we do this with wireless? And that's exactly what they did. So they started out with a very simple use case, which was, let's just give connectivity to these race car driver teams. Now, if you travel with, they're basically data centers on wheels. They do all kinds of analytics. They do all kinds of take measurements on the cars, on the engine, temperature, even the driver and their stats, how well he's doing and so on, or she's doing. But that just, what we've learned here is that was just the beginning, right? They started out as, well, let's just provide connectivity here in the center area. But then once they did that, they said, well, okay, so now we have a network. What else can we do with it? And here's where really I like to sort of talk to people to get ideas on what else they can use these networks for, because they are a general purpose network. So back here, where it says Toyota here, they had, it's a camping area, right? Where I guess they call them groupies that follow these drivers around. They actually stay overnight for the week that they're doing the race and so on. And they also need connectivity. So they provide a connectivity back here. Then they said, hey, we have this area just outside of the track. So the part you don't see on the picture, but it's where everybody comes in, and that's where vendors set up to sell you hearing equipment, right? So you can deal with the noise of the race. T-shirts, all the things that you would expect to happen here, all that commerce happens here. So they also used it to provide those vendors with connectivity to be able to run credit cards and do financial transactions. Again, looking at the security of the network. Then they expanded it to ticket scanning. So now scanning, we're using cell phones with a little sled that can read the tickets. Interactive kiosk, and then finally they expanded it all to security camera. So my point that I like to say here is that you start out with one application and you think, well, I'm going to bring in a private network just to do one thing, and then you realize, well, there's all these other things that I can do with it, right? And that grows over time. We're going to move into one that's also near and dear to our heart, and that's railroad operations. And this is what it's called an intermodal facility. All they do all day is that they take these big shipping containers from the train to a truck, and from a truck to a train. They do that all day, right? But these platforms that you see here, these are actually on wheels, and they have to move up and down the tracks. And these tracks are pretty long. This is about 2 miles from end to end. And they have cameras and other sensors here to make sure that they're doing it. Actually, they moved into a completely remote video system where the operator actually sits in a building over here and not out in the sun and on the elements, and he can control this whole thing remotely. Well, they tried doing it with Wi-Fi, and Wi-Fi just didn't have the reach. It actually works fairly well nearby, but didn't work so well once you get pretty far. And then they said, well, we can go into the cellular network, right? Sure, we'll pay a little bit more, but we can put these cameras on the cell network, and it worked fairly well. There was a cellular network nearby, but what would happen is that there was a bunch of things happening, and of all things, there's also a racetrack nearby that also had events in a certain times of the year. And when those events happens, all those people got onto the cell network, and that ended up siphoning away the capacity, really the network, away from the rail yard into those fans that are, Instagramming and doing the things that they do. Meanwhile, they're trying to run a business here, right? And they can't afford to, lose a day or, even hours of productivity just because there's an event nearby. So they're putting a private network just strictly for control, so that they can, put the coverage exactly where they need it, have it available when they need it, and run their business. That's really what it's about. One with a partner called Boingo that they deployed in an airport, Dallas Love Field in obviously Dallas. And what they did here is really for airport operations. Boingo is really well known about providing Wi-Fi and in some cases cellular connectivity at airports throughout the country. But once they were there, then they said, well, what else can we do with this network, right? And they said, well, there's airport operations, there's luggage carts, mechanics, all these things happening really outside of where you and I would stand, right, and waiting for our flight. So we get great Wi-Fi, but the guys that are really taking care of our planes and our safety, they don't get great Wi-Fi because they're usually outside of that range. So they put in a CBRS network so that they can really get what they need and maintain the planes and take care of your luggage and everything else. Last one I'll talk about as an example here is something very near to our heart, which has to do with school remote learning. So as we all know, with COVID, a lot of the schools are basically, the kids are spending more and more time at home. And of course, not all of them, because of the digital divide, not all of them have broadband at home. So Zoom might not be accessible when they're at home. And what what these guys are doing is that there's a school here, and this is in Utah near Salt Lake City, and there's a whole neighborhood right behind the school, right within a mile or so. And they basically said, hey, can we use our school itself? This is a high school, it's a 2-story high school, and essentially use it as a tower to extend our Wi-Fi network, really, the Wi-Fi network that's already in the school, extend it out into the neighborhood. And that's exactly what they did. And what shows here is, sort of 2 colors. The red is like really, really good signal, but that's mostly in the parking lot and those first few houses here. But really the yellow part is where you get, really good enough for Zoom. Now, we're not talking about, breakneck speeds here, but certainly good enough for Zoom. I think the target that we set here was about 10 megabits to every home through here, right? That's certainly good enough for the types of applications that the kids are going after or are needing to get access to the school. And because this is just an extension of the school, the kids who were taking these devices, and they're mostly sort of desktop type devices that they will go get home and plug them in, but they couldn't use them to just go out and watch Netflix or do something else, right? They had to do it because it still goes back to the school, and then the school applies all those filters that they already had in place, right? Content filters, make sure that the kids were protected from privacy issues and so on, right? It's all extended from the school, as opposed to just, putting them on a cellular network where, the kids can then, do other things other than homework. Okay, we're gonna tackle questions at the back, but I wanted to then talk about, well, how do I get a CBRS network? And I want to talk about sort of the building blocks of this. Because a lot of it really depends on the vertical, and the big block at the bottom here is the devices. You do need some sort of devices. I'll talk about them in a second here, but it's really about having the right device for the right application. Now, of course, cell phones are very flexible and they do all kinds of things, but there might be cases where you need a device that's not a cell phone, and I'll talk about those. After that, then you need radios, and those are fixed radios that go on the wall or out on the roof of the school. And what they do is they provide coverage, just like your Wi-Fi access points. These we call CBRS LTE access points. They get deployed like Wi-Fi, but they provide basically an area of coverage so that these devices can connect. The layer on top of that, and this is really where the sort of the 5G and the sort of the VNFs and things like that come into play. It's a core network in LTE that's called an EPC. And really what that does, does several functions. It handles mobility and things like that. But really one important part that it does, it creates a secure tunnel from a SIM card that's inside this device. And it's essentially a secure pipe all the way through all these, over the air, past these devices, over the school network or the enterprise network, all the way back to that packet core, and where the tunnels are terminated. So you'll see how important that is, because that affects not only your security, but also the latency and the availability of the data that you'll get, right? So that's the packet core. And finally, there is a spectrum access system. It's really a service that was set up by the FCC to really give anybody who's not a mobile operator access to spectrum. That's really what it is. There's a cost for that. It's a monthly cost, typically by access point. But what that does, it gives you the right of way to be able to use the network and then run it in your enterprise. So let's dive into devices here real quick. And of course, there's lots of phones out there. As one of the benefits of the CBRS band being, half of the band, as I showed at the beginning, were for mobile operators. So they also can take advantage of this band, which means that there's going to be devices available for the band. That's always a good thing for the enterprise. But this doesn't end there. There's also tablets and rugged laptops and things like that. So in some use cases, you might find that you need something more than just a cell phone to do whatever application you're doing. There's specialty devices like two-way radios. There's sleds that go onto phones that do ticket scanning and so on. And then there's a whole slew of what we call gateways or bridges. And what these things do is they take CBRS in one end, and then they make it available to a device that might not have CBRS built in, right? Maybe on the other end, it's just simply an Ethernet port that plugs into a camera, right? If the camera doesn't have CBRS, then you add one of these things, and that's how you get connectivity to it. But there's other things. Some of them will create a Wi-Fi hotspot around them, and some of them will basically create what is called a IoT gateway, which it collects data from various IoT devices and then sends it as a single packet back to over the CBRS network back to be processed. So that's the device ecosystem. And then finally, the EPC is what I wanted to spend a minute here, is that because this is really key to 5G services. And I show it sort of, you know, there's an operator EPC, which is the traditional way that cellular has been done. So if you have a device in your facility as an enterprise, and you have a CBR, any kind of private cellular network, what's going to happen is that that information is going to be encrypted. Remember the end-to-end tunnels. Therefore, the enterprise really doesn't have access to that data until it goes all the way up to that operator core network, that EPC, at which point then it gets unpacked, bits put in the clear, and then it comes back to the enterprise to be used. So there are some advantages to this approach, and that is it's pretty easy, right? There's no CapEx. You don't need an on-site server. You don't have to put anything in your IT network to be able to do this, right? It just kind of rides over whatever networks you have, even the internet, back to that EPC, and then it just comes back in the clear. But there are some significant drawbacks, and one of them, as you could imagine, is latency because of that tromboning effect. It goes all the way up there, and then it comes all the way back. But probably not, you know, more importantly, is that the enterprise really doesn't have access to that data until it comes out of the mobile operator, right? The green line is now when you have access to the data. And because it's encrypted, it goes all the way up and then comes all the way back. And then there's, for some enterprises, that's a potential security risk. They don't want to see their data out where they don't control it. So then what we're seeing now is this concept, and you know, we as CommScope, we don't make this, our partners do. So, but we're seeing this as a big enabler to private, networks, and that is that it's essentially either the entire EPC or parts of the EPC are sitting here on an edge server. Sometimes you'll hear the term MEC, mobile edge computing or whatever, but it really what it does, it takes this function of the EPC, puts it here locally within the enterprise. And of course, the drawback of that is that, well, there's some upfront cost of having that there. But then here's all the benefits. Now, the latency, it doesn't have to go all the way outside of the premises of the enterprise to have to come back. It goes, you know, it just gets, it hits this local EPC, this edge EPC, and it gets unpacked right there, it gets put in the clear and then sent to the enterprise. And only that data that's destined for the internet, then that goes out to the internet. But all the enterprise data stays here, which means that they have control of the data. They get to see who's using what, and you know, all that information. Just data never leaves the enterprise. And there are some vendors out there that have something where it has a control plane out on the internet or out on the cloud. But really, as long as the data plane stays local, then the enterprise gets access to the data. And one summary slide, I mean, I think I covered quite a bit in the time we spent together here. I wanted to just, you know, put a plug for Ruckus and our CBRS networks. And it's really, you know, really built for the enterprise. That's what I like to talk about it, right? We took a Wi-Fi type of system, and we added, you know, the cellular technology, the CBRS band, and we made it in a way that's really deployable by enterprises. All right, with that, I'll give it back to Timon, and let's see if there's any questions, or we want to have a little Q&A.
Hey, well, thanks. That was really great. Really appreciate you sharing that perspective. And it is interesting seeing, coming from the Wi-Fi Ruckus background and starting to really embrace and go after the CBRS opportunity. I'm kind of curious about that maybe that journey in some ways for you and for Ruckus.
Sure.
So, at this point, you have kind of an established Wi-Fi business, and the CBRS is, I guess, a relatively new business for you. Is there anything you can share about your expectation of what the split might look like, a year, 2, 5 years down? I mean, where is the market going?
Yeah, I mean, this was actually a big deal for Ruckus at the time to say, for a company that's always been around Wi-Fi and it's always, build a business around Wi-Fi, to say, hey, there might be something else for some use cases where Wi-Fi is just not going to be able to meet it. So we actually had some internal conflict on that as well. And actually, many of our competitors actually, that were in the Wi-Fi business, they poo-pooed the whole CBRS thing, say, well, you really don't need it. We have Wi-Fi, and we're going to get more spectrum, and we're going to get all these things. But really, we realized early on that at the end of the day, the way that Wi-Fi shares, we've continued to improve the technology. We have Wi-Fi 6 or 11AX. We're going to 6E, which is more spectrum, more speeds. But we just couldn't get around the fact that it's contentious spectrum, that there's this listen before talk, that there's a conflict, you got to back off, and that adds randomness to the system, right? And that's really, we just couldn't figure out a way to take that away. And CBRS, with the rules where there's a central database that looks exactly where you are and then gives you a channel based on that, that takes away that randomness, right? And that really what we made us jump into it. And it's been a great journey, right? We saw that early on. None of our competitors saw that. Finally, some of them realized, oh, okay, well, maybe this private networks CBRS thing might be real, so they're gonna go OEM some other products. But it's made it a great journey for us. At the time we started CBRS, we went through a transition. We got acquired 4 times, right? Different companies who wanted access to this technology, and finally we're part of the CommScope family. But it's been a great journey. We started early. We basically created the CBRS Alliance, made CBRS happen, and now we're reaping the benefits.
But to the question of where the market lands or the split, I mean, I've seen some analysts saying it's almost like a 50-50 split down the road. I'm kind of seeing a lot of different projections. I mean, is there anything you can share about the Ruckus?
About the split? Sure. So to the extent that I can share, so remember there were within private networks, there were 2 areas. One was strictly private networks, and the other one was cellular coverage, which I really didn't get into much. Combined between the 2, our expectation is absolutely at least 50% of the Wi-Fi, of the enterprise Wi-Fi market is out there. Combine the 2, right? But a big majority of that is on the cellular coverage. So we do see that the private networks is a relatively small area of it, right? Because they typically try to pinpoint solutions. So it's not going to be as big of a market, horizontal market as Wi-Fi. Right? We're going after enterprise, very specific vertical solutions where the technology fits. Where we're really going to see then the application take off is when you get into cell coverage. And I know I didn't get into it, but what we see as cell coverage, sometimes it's called neutral host. And that is when the enterprise can put a box up on the ceiling inside the building. And now any visitor, anybody who walks in from the street with their own cell phone, then they get coverage from that carrier, right? Verizon, AT&T, T-Mobile. And that, as of today, the operators have not yet allowed that to happen. So we think it's a matter of time. We're actually working with a lot of those operators to make sure they're comfortable with these type of networks, right? Letting their customers kind of roam onto those networks. And of course, in some cases, there's sort of a financial arrangement that needs to be made because that enterprise is providing a service to a user that's in turn paying, that carrier for that service, right? So all those arrangements need to happen and so on. In the meantime, we're just basically promoting and talking about the strictly private networks and those vertical applications. But behind the scenes, we really think that that's where the big payout is going to be.
Yeah, no, good. Makes good sense. Is there anything you can say about the cost differential? You know, deploying Wi-Fi versus deploying a CBRS?
Yeah. So what CBRS is a little bit more. You know, if you put it, you know, we've done some analysis and so on, and it's about a 25% update. You know, sort of you know, cost increase. A lot of it has to do with the core network and some other things that you normally wouldn't need. But again, this is for those high value applications, right? For those, if you really think about the enterprise, they're not going to go deploy it everywhere they have Wi-Fi. They might deploy it where they have those unique needs. However, when you compare it to on the cellular, on the in-building coverage side, the neutral host side, now you're talking about CBRS being a fraction of the cost of the alternatives that are out there, things like DAS and so on, right? So really kind of falls in that in between, right? It's a little bit more than Wi-Fi for private applications, but it's substantially less costly for cellular coverage.
Right. Good. Thanks.
Yeah.
So, so my understanding of your product portfolio is that you work with partners for the core, so you don't do a core yourself.
Correct.
So I would think then, by definition, then you're working with multiple cores, I suspect.
Yep.
And I'm curious how often, you know, you find you know, idiosyncrasies of working with different cores. You know, how that, you know, from that integration, any difficulty?
Right. So, you know, there's always been this dichotomy of, you know, all integrated versus best of breed. And when it comes to the enterprise, it's absolutely the best of breed because of, you know, different enterprises want different things out of their cores, which is great. Yes, we have to go through and done interoperability tests with almost actually all of them that I can think of, including the big guys like Ericsson and Nokia. We've done interop with, as well as some of the smaller ones that are really focused on the enterprise. You know, and the thing is, enterprises, you know, they're really not going to be the guys that we're talking to. They're not going to go put a big Ericsson core into their network, right? They're looking for something that's more of a MEC, something that goes into their IT network. Therefore, again, we go back to best of breed, right? Who makes the best thing that fits in their network, that protects their security and all that? And we just have to work with that. We have found some minor things working with different vendors, but by and large, you know, LTE has been around long enough that a lot of those interoperability things have subsided, and you know, we're almost close to the place where S1, which is that interface between a radio and the core, it really is plug and play. We're almost there.
Right. And then I presume that it's the core vendor or the core partner who deals with the SIM card management or provides that infrastructure for the customer.
Yeah. The SIM card is really tied to that EPC, to that core, right? The RAN network doesn't even see the data that goes through, right? Again, because of that end-to-end encryption between that SIM card and that device all the way up to the core. So the SIM card is the key, the EPC has the lock.
Got it. Yeah, because I would imagine for enterprises, you know, managing the SIM cards and whatnot is, I guess it depends on the number of devices, but that could be a complexity for them.
Absolutely. And we've seen where, you know, if they have only a few factory things, they'll just get physical SIM cards and stick them in. To others where they need a very sophisticated SIM card management. For example, in retail, you have a lot of turnover, right? We're talking this, you know, lots of turnover. So they wanted the ability for the SIM card management to be tied directly to their payroll and employee networks, right? So when somebody quits, right, which happens every week, they immediately get turned off or whatever, right? And of course, they're really demanding now going to eSIMs, again, because of that cost of that physical card left out, you know, when that person left.
Good. Makes good sense. So the last question I have is maybe, it might be off topic, it might not, but I'm curious about, you know, ORAN and, you know, sort of the OpenRAN movement. It is more of a telco-driven movement, but where we are seeing people kind of looking at and or talking about at least the first application for more OpenRAN implementations being, you know, private networks. You know, they're essentially greenfield and easier to deploy. I'm curious about Ruckus's, you know, thinking about kind of sort of that ORAN movement and what implications you think it might have for this market.
Yeah, I think, let me kind of put it a different way. So we're really focused on the enterprise of today's with our Ruckus products. But yes, we are looking at ORAN and some of our other products that are more carrier targeted at the carrier. So we have a product called OneCell, and that's, so anything that goes in that direction, like you said, those are more telco driven. I mean, we don't have an enterprise customer who comes to us and say, hey, I want an ORAN, this or that, right? And we mentioned interoperability. It's taken us years just to establish that interoperability between an EPC and a RAN, right? Now you're talking about taking to the next level, which is between a RAN, part of the RAN, and then the radio heads that are deployed out there, right? And that's still probably a little too early to try to bring that into an enterprise. But it could happen. It certainly could happen, and we're certainly part of it and watching it.
Yes, no, understood. And definitely it is early. I guess I bring it up because, the interesting discussions I'm seeing around starting to do spectrum optimization for enterprise application, and if, you got, right now spectrum's optimized for macro cells and outdoor deployments, but yeah, I agree. It's not ready for consumption now. I'm just curious, since you've coming kind of from the enterprise side, on this, and from the Wi-Fi side, curious of your perspective.
Yeah, those things really make sense. If you're a mobile operator and now you're trying to serve an enterprise, then you need things like network slicing. You certainly need that MAC to be able to provide, so when they talk about, the operators talk about offering to the enterprise, they're basically taking the macro network and making it fit in. We're coming from a different world, right? We're coming from Wi-Fi. So they have to, there's nothing to slice, right? They have the whole pie. That's what I say, right? They have, by putting that EPC in the network, in their IT network, they already get all that benefits that the mobile operators have to purposely kind of break off a piece of their EPC in the cloud and then put it into an enterprise. When you do CBRS with Ruckus, it's all right there. You already have the whole network.
Got it. Good. Well, Juan, thank you so much. Really appreciate you spending some time with us today, and really great to see, kind of your perspective on this space, exciting space, and I'm sure we'll be seeing more in the year to come.
Great.
Thank you.
Thank you. All right.